Let's talk about solving rational equations. There are two main types of rational equations that you might come across. The first type is when you have one rational expression or one fraction equal to another rational expression or fraction. In that case, you can just cross multiply and then solve the equation you have left. On the second type, you might have more than two rational expressions within the equation, and in that case, you have to find the least common denominator and then multiply every term in the equation by the least common denominator and then solve the equation you have left. So let's check out some examples. These are three examples of type 1 rational equations. So these all have one rational expression equal to one rational expression. So we can do your favorite method of all time and cross multiply and then solve the equation we have left. So for example 1, 3 over x equals 12 over x plus 7. We can cross multiply, so we get 3 times x plus 7. It's good to set that up in parentheses so you don't forget to distribute the 3. And set that equal to 12 times x. So when we distribute the 3, we end up with 3x plus 21 is equal to 12x. So then we could move the 3x over, so we have the x's on one side. So we get 21 is equal to 9x. And then we would need to get x by itself, so we just have to divide by 9. And all we can do here is reduce the fraction. So x will end up being, let's see, if we divide by 3, we get 7 over 3. And we could just leave it like that. Let's look at example 2. What if we have x over 5 equals x plus 3 over 8? So again, we cross multiply, and then we'll solve the equation we get after that. So we get 8 times x would be 8x is equal to 5 times x plus 3. So again, I would make sure you put that in parentheses so you distribute the 5 properly. So then let's go ahead and do that. So 5 times x plus 3 would be 5x plus 15. Bring down the 8x. And then we need to get x's on one side. So I always say to try to move the smallest one so you keep your x term positive, or whatever the variable may be. So 8x minus 5x. I'm going to bring my work over here where I got a little more room. So 8x minus 5x would give me 3x. And then 5x went away, so 3x is equal to 15. And then we just simply have to divide by 3. So we get x equals 5. Now if you wanted to check your answers, you can plug them back into the original problem and see if they would make a true statement. So for instance, if I plugged 5 back in, is 5 divided by 5, so I'm replacing x with 5, equal to 5 plus 3 over 8. So then I would say 5 over 5 is equal to 1. Is that equal to 5 plus 3, which would be 8 over 8? And 8 divided by 8 is equal to 1. So that would be a way you could check your answer and make sure that it makes good sense. Now let's look at the last example for type 1. So we cross multiply 2 times x minus 15 is equal to 4 times 3x minus 5. So then we have to distribute the 2 and the 4. So 2 times x minus 15 will give us 2x minus 30. And 4 times 3x minus 5 will give us 12x minus 20. So I need to combine the x's on one side. So like I say, move the smallest term with your variable, so that way you keep things positive. So if I subtract the 2x, let's see, I'm going to bring my work over here since I've run out of board space over there. So continuing my problem over here, let's subtract 2x. So we get negative 30, don't forget your negative sign, is equal to 10x minus 20. And then we need to put the numbers on one side. So let's add 20. So I end up with negative 10 is equal to 10x. divide both sides by 10, so we're just finishing up solving our equation, and we get x equals -1. So you could plug -1 back into the original problem if you want to check your answer and make sure that it makes sense. So let's look at some examples of type 2. So with type 2 rational equations, you have more than 2 fractions within the whole equation. And so what you have to do with these, you can't cross multiply. You have to find the least common denominator and then multiply every term in the equation by that least common denominator and try to cancel denominators so you're left without fractions. So let me show you what I'm talking about. We have 2x and 3x as our only denominators because 2 technically has a 1 underneath it. So the least common denominator for those two would be 6x. So you go through and multiply every term by 6x, the least common denominator, and it'll help you to cancel all the denominators in the whole equation if you've done this step properly. So for instance, 2x divides evenly into 6x. So they would reduce. 2x divides into 6x and will leave us with 3. 6x divided by 3x will leave us with 2. And then 6x divided by 1 is still 6x, so we leave that one there. But then we go back through the problem. Now I have 3 times 3, which is 9, minus 2 times 5, which is 10, is equal to 2 times 6x, which is now going to be 12x. So then we clean that up. 9 minus 10 would be -1, is equal to 12x. Divide both sides by 12. So in this case, my answer is -1/12. And I would leave it as a fraction. Don't get a decimal, because you would most likely see a fraction on a test question. So for example 2, we have 3 fractions again. So you look and see, for each fraction, we would need to find the least common denominator. In other words, what could I turn all of those denominators into so they'll all be the same? So I have y, I have 2, and I have 2y. So 2y would be my least common denominator because it would include 2y and 2 and y. So I put 2y, we'll multiply each term by 2y, put them at the top. And then I go through each fraction. So 2y divided by y, the y's will cancel out. 2y divided by 2, the 2's will cancel out. And 2y divided by itself will completely cancel out. So what this is doing is it's getting rid of the fractions. So you're left with a nice equation that's much easier to solve. So that's our first goal, is to really get rid of the fractions, or rational expressions as we call them. So 2 times 2 will leave us with 4. We have 1 times y, so 4 plus y is equal to 5, and then those canceled out completely. So see, that's nice and simple now. We've got rid of all that complicated stuff. Subtract 4, and we just simply get y equals 1. And just like on the first set of examples, you could plug in y equals 1 back into your original problem and just make sure that it would make a true statement. So let's look at the third example. This one is the one from the first board. This has 4 fractions, but it would work the same way. So we look at 2x, 3x, and 6. And we think about what would be the least common denominator. Like, what could I turn all 4 of those into with the least amount of work? So 6 is large enough that I could turn 3 into 6, and I could turn 2 into 6. And then we need to have 1x, because no denominator has more than 1x. So 6x would be the perfect least common denominator to help me clean up this rational equation. So 6x divided by 2x, we go through and cancel each one and reduce it down, would leave us with 3. So 6x divided by 2x left me with 3. 6x divided by 3 would leave me with 2x. 6x divided by x will leave me with 6, and 6x divided by 6 will leave me with x. So again, it's a nice place to write neatly, or you might get confused as to what's left over right there. So let's go through carefully. We have 3 times 5 now was 15, minus 2 times 2x, so minus 4x is equal to 1 times 6, which is 6, plus 5 times x. So on the second step of your problem, you should have a nice equation that's not got any fractions left because you've gotten rid of all of them successfully with your least common denominator. So we want to put variables on the same side, move the little one. So -4 is smaller than 5x. So I'm going to move that one over. So I get positive 1x. So we get x, bring down the 6. The 4 and the -4 canceled out. And we have 15 equals 6 plus x. So if I subtract 6, I get x equals 9. And if we had more time, we could check all these answers and plug them all back in and show you how they work. But to get through a few more examples, I'm just going to remind you that you could check 9 and make sure that it would make good sense. But I have 2 more examples for us to look at. So these 2 equations, but let's start with our first method, which was cross multiplying. So we get x squared minus 25 equals x times x minus 5. So we get x squared minus 25 equals x squared, because I've got to distribute my x, minus 5x. So now, let's see, we have x squared on both sides, so if we subtract x squared, that's going to cancel out on both sides. I have negative 25 equals negative 5x. So I still need to divide by negative 5. So 5 will equal x. So we could again plug that answer back in and check our work and make sure that 5 would make good sense. But let's look at example 2 for now. For this one, we have some factoring we need to do to figure out the least common denominator. So it ended up on example 1 here that we didn't have to factor. We could just continue with our method of cross multiplying. So let's look right here. If we factor out x squared minus 7x plus 12, we get x minus 3 and x minus 4. They multiply to be positive 12. They add up to be negative 7. And now we can tell what our least common denominator will be. It's got to be that whole set of factors, x minus 3 and x minus 4, because that would include these other 2. And so if we multiply by x minus 3, x minus 4, which will seem like a lot of writing, but it helps us to see what happens in this next step where it's going to clean up. So we write all that down, but then we're going to have a whole bunch of stuff cancel out to make this a lot easier in just a second. So if you notice, x minus 3, x minus 4 is being multiplied and divided. So it completely cancels out that denominator and you're left with 5. X minus 3 is going to cancel x minus 3. And now I'm left with minus 2, because don't forget you're subtracting right there, times x minus 4 equals, and now x minus 4 cancels out and I have 5 times x minus 3. So then we have an equation that we're able to solve from there with no fractions. So we could distribute negative 2. So 5 minus 2x plus 8 equals, and distribute the 5. So we get 5x minus 15. Now we need to combine like terms. So 5 plus 8, I'm going to move my work over here. 5 plus 8 will give me 13 minus 2x equals 5x minus 15. So move the term that's the smallest with your variable. So if we add 2x, we end up with 13 equals 7x minus 15. I'm going to add 15. So I get 28 equals 7x. And when I divide both sides by 7, I get x equals 4. So we could plug 4 back in to our original problem, which might take you a minute, but you can still check your work. And it's always good to have a method to check your work with, just to make sure that you're right.